The review video for graphing systems of inequalities is going to be really short. We're going to do one example, and then we're going to check our answers for one single problem. Before we start, to make sure we are on the right track, we have systems of inequalities. So systems means more than one. So we usually are talking about two, either lines, but in this case, we're looking for inequalities or linear inequalities, which are when we're graphing a line type object, but then we have some shading either above or below that line. So let's get into an example quickly. For the top line, we are already into slope-intercept form, which means our slope is -3 or -3 over 1. And our b value, which is right here, would be +1 or the ordered pair 0, +1. That means our b value is right here, and then our slope helps us find extra ordered pairs. Just like I said in the last video, if you need more practice with graphing using slope-intercept form, by all means come talk to me, but I'm going under the assumption that we've done this close to 1,000,000 times, so you're probably sick of it by now. I know, shocking to hear. We then have to ask ourselves, is this a solid or a dashed line? And I see just less than, so that makes this a dashed line, not solid. And then we have to figure out, are we shading above or below? So this is just less than, so I'm shading just below this line. Like before, I'm not going to shade too heavily, though, because we have another line to graph. For our second line, we need to put it in slope-intercept form, which means I need to subtract 3x from both sides. I get -2y is less than or equal to -3x plus 9. From here, I need to divide everything by -2. And because I'm dividing by a negative, I need to remember to flip the sign, which is greater than or equal to, I'm going to make this +3/2 x minus 9/2, which I'm going to write as the decimal 4.5 or 4 5/10, which means our slope is 3/2, and our b value is -4.5. And the reason why I wanted to graph one of these is to show you that you could plug in numbers into each equation and see if it makes a true or a false statement. But honestly, for some of these, it's easier to just graph it and then see where the ordered pair lies. Because graphing this line is not necessarily very easy, but I will tell you that for the next part, finding where our ordered pairs are is a lot easier if you have it in a line instead of a single set of equations. So here we are. This is a solid line, not a dashed one, because we have less than or equal to. Now we're graphing greater than, so we need to be above the blue line and below the black line, which means we are in here. This is our answer. So the only part that's not going to be true is anything that's underneath here, which is right here. Let's try to not erase the whole line. And there is our system of inequalities. Now I'm going to copy this graph over to try the next part. Once again, I want to check to see if these ordered pairs are a solution to the system of inequalities, which means are they in the shaded region of both lines. The point 3, 3 is right up there. I'm actually going to graph this in red, which is not in the solution of system of inequalities, so I write no. 4, 6 is right up here, also not in the solution set. 2, -1 is down here, which is also a no. And then finally, -2, +2 is right up here, which is in the solution set. So we would say yes. So this section doesn't teach us a lot of new stuff, but it does combine a lot of skills that we worked with before. As always, if you have any questions, please let me know.